In order to solve this problem, I find it's helpful to create a little table of values. On the left side of the table, we're talking about the number of sides. So a triangle, which has 3 sides. And on the right, we're going to have the sum of the interior angles. So triangle, the sum of the interior angles is 180 degrees. For a 4-sided polygon or a quadrilateral, the sum is 360 degrees. A 5-sided pentagon, the sum of the interior angles is 540. And what we're trying to get to is a hexadecagon, which has 16 sides. Now, the question's not asking us for the sum of the interior angles of a hexadecagon. It's asking us for the measure of one of its internal angles. But we can figure that out pretty quickly if we do know the sum of all 16 of them, because we would just then divide it by 16. So let's try to figure out a pattern here. Notice that as the number of angles increases by 1, the sum of the interior angles is being added by 180 degrees each time, adding 180. So you can imagine from a pentagon all the way up to a hexadecagon, we need to add 180 degrees. How many times? Well, to get from 5 to 16, that's a difference of 11. So think of, we need to start from 540, we need to add 180 degrees 11 times. So we're going to multiply that by 11. That works out to 2,520. And by the way, another way we could have figured this out is if you do, there is a formula for the sum of the interior angles of a polygon. And you might have that memorized, you might not, but the sum is n minus 2 multiplied by 180, n representing the number of sides. And you would notice in this case, if we did 16 minus 2 multiplied by 180, you do in fact get the same answer, 2,520. So a couple different ways here to get to that answer. But remember, the question's not asking us for the sum of the interior angles, it's asking for the measure of one of them. So pretty simple step there. All we need to do is to take the sum of all 16 angles, divide it by 16 to get the measure of one of those interior angles, which happens to be 157.5 degrees. All right, hope that was helpful, and thanks for choosing JD's Prep.